The first problem says Trey makes $6 per hour plus an average of $2.12 per hour in tips. How much will he make if he works 2.5 hours? So there's a couple of things here. There's $2 per hour numbers. The first one is $6 per hour. That's how much the restaurant pays him. And then also $2.12 per hour in tips. And then it's asking us how much will he make over a 2.5 hour period. So if we know how much he makes every hour, and then if we know how many hours he works, we need to multiply those numbers together. If he works for 1 hour, then we already know how much he makes per hour. If he works, for instance, 2 hours, then we'll double the number in order to figure it out. So we're basically multiplying by the number of hours here. But in this case, we're told $6 per hour in wages, but $2.12 per hour in tips. So actually, we need to figure out how much he actually makes per hour. So it's $6 per hour, and then also $2.12 per hour. Now, when we add decimals together, we need to line up the decimals. We want to add them because we want to know the total amount of money he makes per hour. So you can see here, we add this, we get a 2, add this, get a 1, 6 plus 2 is 8. So he actually makes $8.12, which is that many dollars per hour. So we now know how many dollars per hour he makes. So let's set it up in terms of a table. The way we would write this is $8.12 per, when we put a line like that, per hour. And if you want, you could put per 1 hour. What's really happening is when we talk about getting $3 per hour or $2 per hour or $10 per hour, what we really are saying is $3 per 1 hour. That's what dollars per hour is. It's per 1 hour. So you can put the 1 here if you want, but it's not going to do anything because dividing by 1 is not going to change anything. So we write down $8.12 or $8.12 per hour. That's the best way to say it. And then we have to look in the problem. It also says we work for 2.5 hours. Now, if we put 2.5 hours down here, nothing will cancel. So we have to put it up here, 2.5 hours. Up here. Why are we doing it up there? Because now that we have hours on the bottom and hours on the top, they cancel. And this is telling us that we need to take the 8.12 and multiply by the 2.5. That's what I said when I read the problem and we thought through it. We need to multiply the dollars per hour times how many hours he's working. And so this is telling us that we need to do that. If you're not sure, this table will tell you what to do. So to solve the problem, we take $8.12 and we multiply by 2.5. Notice when we multiply decimals, we do not line up the decimal points. We just line the numbers up, and then we just proceed as usual. Working with 5. 5 times 2 is 10. Carry the 1. 5 times 1 is 5. 1 more is 6. 5 times 8 is 40. So we put the 40 right here. Now we need to multiply by the 2. We drop a 0. 2 times 2 is 4. 2 times 1 is 2. We don't add this because that's from the previous step. 8 times 2 is 16. So the 16 goes right here. Now we have to add all of these numbers together. So what we're going to get is a big 0 right here. 6 plus 4 is 10. So we have to carry a 1 right there. 2 plus the 1 is a 3. 6 plus this 4 again is 10. And we carry a 1, and then we have a 2 in the front. So we have 2, 0, 3, 0, 0. Now, where does the decimal go? We have 2 digits after the decimal here, and 1 digit after the decimal there. So in the problem, we have 3 digits after the decimal. That means the decimal must go right here, 20.300. Now, we can write it like this, but the answer is in dollars. So when we talk about dollars, you usually want a decimal with 2 spots because it's dollars and cents. So you can write 0.300, but really what we're trying to say, this is $20.30. And we can just drop that last 0 because remember, trailing zeros in a decimal don't do anything. Even this 0 really doesn't mean anything, but we put it there so we can read 30 cents a little bit easier. So we can drop it because the trailing zeros in a decimal don't matter. So how much money did he earn? He earned this many dollars. $20.30, or you can say $20.30, however you want to say it. All right, and the 2 steps in this problem, the first step was to add the decimals to figure out how much he's making per hour, and then finally to multiply to get the answer in dollars. Now, we need to read the next problem carefully. It says, milk costs $3.21 per gallon. If Caitlin spent $21.35 at the store, with $2.09 spent on candy and the rest on milk, how many gallons did she purchase? So there's a lot going on here. We need to really pick it apart. So we know how much the milk costs per gallon, $3.21. Put that in the back of your mind, in your back pocket for now. Let's focus on the rest. Caitlin spent $21.35. However, $2.09 was spent on candy. The rest was spent on milk. So let's first figure out how much money she spent on milk. All right, how much money she spent on milk. So we know from the problem statement that she spent a total of $21.35. We know that she spent on candy $2.09, and we're going to subtract these because this is the total dollars, and this is the candy. So if she only spent money on candy and milk, if I subtract the candy, then what's left over must be the milk. So what do I have here? 5 minus 9, I can't do that, so I make it 15, and I borrow to make that a 2. 15 going down by 9 is 14, 13, 12, 11, 10, 9, 8, 7, 6, and we land on 6. So we have a 6 down here. And then we have 2 minus 0, which is 2. 1 minus 2, we can't really do that either. So we will borrow, making that an 11, and we'll change that to make it a 1. So 11 going down is 10, 9. 9 goes here. 1 minus 0 is 1. And remember, when we add or subtract decimals, the decimal just falls straight through into the answer. So we spent $19.26 on milk. That's what we really wanted to figure out in the first part of the problem because it tells us milk costs $3.21 per gallon. How many gallons did she purchase? Well, now we know how much money she actually spent on milk. And we also know the price of a gallon of milk. It's $3.21 per gallon. So you might not be sure, should I multiply or should I divide? Let's say you don't know. If you don't know, then we're going to write it down in a table and we're going to figure it out. We're going to write down, first of all, that we spent $19.26. So I'm going to write this as $19.26. Yes, I know it's dollars and cents, but really it's $19.26. That's the way to write it and really kind of keep it simple. That's how much money she spent. And then it says in the problem that milk costs $3.21 per gallon. So we want to come up with gallons. How many gallons did she purchase? So the only way to write this is to write it as $3.21. So I'll write this as dollars per 1 gallon. Remember, when I look in the problem, I can flip it over either way, but if I flip it the other way, $3.21 per 1 gallon on the bottom, nothing will cancel. But by arranging it this way, dollars cancels with dollars, and the only thing I have left is gallons. And the problem said, how many gallons did we purchase? So what this is telling me to do is take the $19.26 and divide it by $3.21. Multiplying by 1 will not do anything. Now let's see if it makes sense. If I know how much money I spent on the milk altogether, and I divide by 321, what it's telling me is how many gallons I purchased, because every 321 that I spend goes to a gallon. If I divide this and it fits 3 times in there, then that's 3 gallons I spent, because every gallon is worth $3.21. So I want to figure out how many times this goes into this. So then I'm going to do that division, $19.26, and I'm going to divide that by $3.21. But remember, when we divide decimals, we just learned we don't want decimals on the outside, so we move the decimal twice, and that makes us move the decimal twice here. So this problem I'm really going to solve is 1926 on the inside. On the outside, 321. Right, 321. So it looks like a big nasty problem, but really think about it. You can't divide into 1, it's too small. You can't divide into 19, that's too small. You cannot divide into 192, that's also too small. How many times can you divide into 1,926? So 321 times something is as close as I can get to this. I don't know. I can try multiplying by 3, multiplying by 4. Let's try multiplying by 6. 321 times 6. 6 times 1 is 6. 6 times 2 is 12, carry. 6 times 3 is 18. One more is 19. And look at that. It equals exactly 1926. So it's multiplying by 6. Multiply, you get 1926. You get a remainder of 0, and there are no other, nothing else to drop down. So what do we learn from all of this? It means that when you take $19.26 and you divide by $3.21, the answer that we get is just 6, exactly 6. 6 what? The only unit we have left is 6 gallons. So what this means is we know that Caitlin spent $19.26 on milk. And when we divide this in, it fits exactly in there 6 times. Every time we divide in and fit another 326 in, that's another gallon of milk. And it fits in exactly 6 times, so we must have bought 6 gallons of milk. And if you don't really know that you should divide, this will tell you that you have to divide because the gallons is the one that we want, and that's the only thing left over. All right, let's take a look. Problem number 3, it says Mark can type 53.5 words per minute. If a document already has 120 words typed, how many words will it have after Mark types for 5.3 minutes? So we have a document. It's already open. It already has 120 words on there. That's what's already on the document. Then I sit down to type. I type for 5.3 minutes. I'm I'm typing. And I know that I type 53.5 words per minute. That means every minute I type, I type another 53.5 words. So to figure out how much I'm typing into the document, I take the 53.5 words per minute and I multiply by 5.3 minutes. That tells me how many words I have typed. Now, I hope that makes sense to you, but if it doesn't, then just write down the numbers from the problem. 53.5 words per means we put a line under it, words per minute. Or words per 1 minute. You can put a little invisible 1 there. And then the problem says I type for 5.3 minutes. If I put 5.3 minutes here, nothing cancels. But if I put 5.3 minutes here, then I can see that I have minutes on the top and minutes on the bottom, and so they cancel away. This is telling me that I must multiply the 53.5 times the 5.3, and the only unit I have left is the words. That's the words that I typed. You see, the logic, we just explained why it works, but now you can see how just by canceling units, you can figure out what to do, even if you aren't totally sure. So the first thing we need to do is take 53.5, multiply by 5.3. And then we go and crank through it. What do we get? We have 3 times 5 is 15, carry the 1. 3 times 3 is 9. 1 more is 10, carry the 1. 3 times 5 is 15. 1 more is 16. So there we go. We're going to multiply by the 5. We drop a 0. 5 times 5. Let me actually switch colors probably. Let's switch to red. 5 times 5 is 25. Carry the 2. 5 times 3 is 15. We have to add this. 16, 17. Carry the 1. 5 times 5 is, again, 25. 1 more. 26. Now I need to add these numbers together. So what am I going to have? The 5 drops down. The 5 drops down. 6 going up. 7 going up. 8, 9, 10, 11, 12, 13. Carry the 1. 6, then 7, then 8 goes here. The 2 drops here. So I get 2, 8, 3, 5, 5. Now for the decimals, I have 2 decimals after the decimal. 1 from here and 1 from here. So I must have 2 digits after the decimal in my final answer. So what this is telling me is that if I type 53.5 words per minute, and I type it out for 5.3 minutes, then I have typed 283.55. That means almost 284, a little bit more than 283 words typed. Because remember, words per minute times minutes, this is the only unit left, words typed. But that's not all, because it says the document already had 120 words in it. And now we know that we just typed out this many words. So how many words do we have altogether on the page? That's what we're trying to figure out, right? So I take the 120 words and 283.55. Now in order to add these, I want zeros everywhere. So I remember there's always an invisible decimal after a whole number, and I can put zeros here. So I'm going to add these numbers together. The 5 drops down, the 5 drops down, the 3 drops down, 2 plus 8 is 10, and then 2, 3, 4 goes here, and the decimal just drops right down. So what have I figured out? The total amount of words on the page is 403.55 words total on the page. So again, I sat down at my computer, I already had 120 words on the page, and I start typing. When I'm typing, I calculated that I'm going to type an additional 283, just a little bit more than 283 words. So I add that to the amount that was on there, and this is what I get, 403.55 words total. All right, only 2 more. The next problem says Carol bought 1.4 liters of juice and $1.5 or $1.50 of coffee beans for $5.42. What is the price per liter of juice? We want price per liter. We have to arrange the units in such a way that the one that we get out is dollars per liter. When it says price per liter, we want dollars per liter. That's what price per liter means. How do we get that? Well, we know how many liters of juice she bought, 1.4 liters. And then it says we bought $1.50 of coffee beans, and we also bought the juice, and the total was $5.42. So what we really know is that the total amount of money spent was $5.42. That's how much was spent total at the store. That's how much money I spent. But it also tells me that I spent $1.50 on coffee. Right? So what we want to do is subtract these numbers. Why do we want to subtract them? Because we want to figure out how much money we spent on juice. We want to know the price per liter of juice. We need to know how much dollars we spent on juice. So if we know we spent this much total, and if we know we spent this much on coffee, we will subtract, and that will tell us how much of the money we actually did spend on the juice. So we have to subtract. We have 2 minus 0 is 2. The 4, we're going to have to borrow, making 14, and then this will become a 4. 14 going down is 13, 12, 11, 10, 9. 9 goes here. 4 minus 1 is 3, and the decimal point just drops right down through, and this is the amount of money I spent on the juice. Juice. All right, so now the problem is easier because if I just told you, hey, you spent $3.92 on juice, and for that price, you bought 1.4 liters of juice. Tell me the price per liter. Price per liter. You might think, well, how do I find that price per liter? Well, I know the price and I know the liters. I know the dollars, I know the liters. All I do is divide them to find the price per liter. That's all I do. And if you, again, aren't sure, just put it in this table. $3.92. This is dollars. Dollars of juice per... How many liters do I have? 1.4 liters. So I want to know the price per liter or the dollars per liter. So I just take the amount of dollars I spent, divide it by the amount of liters I spent it on, and that's what I will get. How do I do this? I take $3.92 and I divide it by the 1.4. But again, I realize that I have to move this decimal 1 position to actually do the division. So what I'm actually going to do is say 39.2 divided by 14. 14. All right, so now I have to do this division. 14 times what is 39? It's probably going to be 2, but I'm not sure. Let's multiply. 2 times 4 is 8. 2 times 1 is 2. That's 28. That's pretty close to 39. If you're not sure, go 14 times 3 and see. 4 times 3 is 12, carry. 3 times 1 is 3. 1 more is 4. That's 42. That's going to be too big. So it has to be 2. This divides in 2 times, and 2 times 14 is 28. 9 minus 8 is 1, and 3 minus 2 is also 1. And after I subtract, I always grab the next decimal or the next digit and bring it down. In this case, it's a 2. So now 14 times something is going to get me as close to 112 as I can get. It's got to be way bigger than 3. I mean, maybe 6, maybe 7, maybe 8. I'm not totally sure. So let's just try 14 times 8. 8 times 4 is 32. Carry the 3. 8 times 1 is 8. Then we go up, 9, 10, 11. And that's exactly to 112. You may not know it's exactly 8. You might pick 7. You might pick 9. Eventually, you'll figure out that's the closest. So it can go 8 times. And then 8 times 14 is 112. And of course, then the remainder is 0, and we're done. And don't forget, the decimal just floats right above the decimal point there. So the answer is 2.8. 2.8. But notice we're asking ourselves per dollars per liter. So instead of writing as 2.8, we can just tack a 0 because we're reading money. So dollars and cents is easier, $2.80 dollars per liter. So when someone asks you for the price per liter, or the price per gallon, or the price per anything, it's just dollars per whatever it is. This is basically telling you that if you know that you spend $3.92 on something for 1.4 liters, then when you divide it, you get this number. This is telling you the price for every single liter. Think about it. If you spent this much for more than a liter, then this price makes sense that it would be the price for just 1 liter, because you spent this much and you got way more than a liter, 1.4. So the price for only 1 liter should be less. This number, $2.80, is the price per 1 liter. That's what it actually means. All right, we have one last problem. It says last week, the rainfall averaged 0.75 inches per day. How many inches did it rain over the 7 days? Another question, there's actually 2 questions here. How much rain, or how much will it rain over 3 weeks if the average rainfall remains the same? So we have a unit here. It rains inches per day. When you put the rain gauge outside, it collects the rainwater. You're just measuring how tall the amount of water is in there. That's telling you how much it rained. And it can be inches or centimeters or other units, but this one's in inches per day. So it averaged 0.75, which is a little bit less than 1 inch per day. So if we know that that's how many inches happen in 1 day, then over 7 days, we have to multiply by 7. So that's what we're going to do. Now, if you're not totally sure, we can just set that conversion table up, which is, I think, always a good idea anyway. So we can go over here and we can say, well, if it's 0.75, I'm going to put inches per day, right? Inches per day. And it rained how many days? 7 days. I don't want to put the days down here, then nothing will cancel. I have to put the days up here. And then you can see that days cancel with days. The only unit that you have left is inches. So you know you have to multiply. So let's take 0.75 times 7. We'll say 0.75 times 7. 7 times 5 is 35. Carry the 3. 7 times 7 is 49. 50, 51, 52. Carry the 5. 0 times 7 is 0, plus 5 is 5. Now, for the decimal, we have 2 decimals or digits after the decimal here and none here, so we must have 2 digits after the decimal here. So what this means is we must have collected 5.25 inches of rain because the days have canceled, so we'll just say inches of rain over 7 days, because that's what we did. We multiplied by 7. Now, the second part of the problem says, how much will it rain over 3 weeks? Again, if the rain remains a constant every single day. Well, when you think about it, 7 days is a week. So I multiplied by the 7 and I got it in terms of, this is how many inches rain over 7 days. But 7 days is a week. So if I really want to know how much it happens over 3 weeks, then, and this is a week, just 1 week by itself, then I should take this number and just multiply it by 3. That will give me the amount of rain over 3 weeks. So I'll take 5.25 and multiply by 3. 5 times 3 is 15, carry the 1. 2 times 3 is 6, 1 more is 7. 3 times 5 is 15. And the decimal, I have 2 positions here and none here, so it must be here. So what this means is 15.75 inches over 3 weeks. So in the first part of the problem, I calculate how many inches happen over 7 days, which is also the same thing as per 1 week. And then to find 3 weeks, I just take that number times 3, and then it's 15.75 inches of rain over 3 weeks. So here, we have conquered a lot. We have learned. So that not only concludes this lesson, but it also concludes this unit where we have learned about place value of decimals and the tenths and the hundredths and the thousands place. We've learned how to add and subtract decimals. We've learned how to multiply and divide decimals, and we've learned how to solve real problems that have decimals. I'd like you to practice all of these problems. Build your skills, build your confidence. When you feel like you understand what you're doing, follow me on to the next lesson. In the next unit, we will continue building your skills step by step. Learn anything at mathandscience.com.